All right, folks, it's 2 o'clock. We'll go ahead and get started. And for those folks that still need to join us, they can jump in here in the next couple of minutes. I do want to start out just by saying that we're going to be starting this 6-week series called Climate Smart Floridians. This is a curriculum program that was developed by the University of Florida Sea Grant Climate Action team, and the goal is to increase climate literacy and reduce local greenhouse gas emissions throughout Florida. And it's kind of, the material is modeled after the Climate Masters program that was piloted by the University of Oregon. So I just want to give you a little bit of background on that. So this is a curriculum that again was developed by University of Florida Sea Grant, and it has been provided to agents throughout the state and modified by those agents to make it locally relevant. So that's what we're going to be talking about today. And I want to first just thank Eileen Valdez for giving me the opportunity to promote this webinar series through Manatee County Libraries. And I'll give her a chance to jump in and say a little bit about the library and talk about any relevant information she wants to share.
Hello, everyone. Again, I'm Eileen Valdez with the Manatee County Public Libraries. I'm the Assistant Supervisor at the Palmetto Library. Thank you, Alyssa, for what I'm sure is going to be another great informative class, the start of the Climate Smart Floridian series. And again, folks, if you guys can't make it to all of the series classes, we are going to be recording these, so just come in whenever you can. The libraries, Manatee County Libraries, are now open. We're all at 40% capacity, which is different for, of course, all the branches. And we're all open, mainly our normal hours, closing an hour early every day to disinfect the high-touch areas. But we are continuing with our Zoom programming for now, no in-person programming. We have launched our child summer reading program, so information should be on our website for that, and also take a look at all of the other Zoom programs that we'll be having. And for now, I'll give it back to Alyssa. Thank you.
Thanks, Eileen. I have disabled the chat for the webinar today, but if you'd like to put a question in the Q&A, that's how we'll be fielding the questions. I apologize, it looks like there may have been some issues with the sound there. Hopefully it came through on the recording all right. Everyone that registered for the webinar will receive an email as a follow-up with the recorded presentation. So we'll go ahead and get started today. Again, my name is Alyssa Vincent, and I'm the residential horticulture agent at the Manatee County Extension Office. And you may think, okay, you're a horticulture agent, why are you talking about climate change, right? Well, there's a lot of synergies I think you'll see between actions that we take in our landscapes and personal decisions about how we engage with our local natural communities that have an impact on local resiliency as well as adaptations to global climate change. So I kind of jumped right on board with the Climate Smart material when I found that it was available. I have a background in environmental science and policy and ecological restoration, so it was right up my alley. And I'm really excited to offer this webinar series with you all. Today is the kind of jumping off point for us. So we're going to start off by covering some of the basics. But before we begin, I do want to highlight some information if you are not familiar with extension, which I looked at the participant list and it looks like most of you are familiar with us. But if you're new and you're not familiar with extension, we are a function of the land-grant university system. And here in Florida, we work through the University of Florida, and each Florida county has an extension office. Our job or our role as extension agents is to take relevant research that's conducted at the University of Florida or with some of our educational partners and provide that information to the public in an accessible and meaningful way. So recognizing that we have a responsibility to engage our communities and make information that is scientifically up to date, relevant to their daily lives. And through that sharing of that information, we can hopefully improve your quality of life. So that is our role as extension agents. And specifically in Manatee County, that's expressed in a variety of different programs. We do offer CEU opportunities to landscape companies, pesticide license holders, and you can see this is our 2019 impact slides. We had over $2 million in value of new licenses and CEUs within our community. We operate a Master Gardener volunteer program as well as a 4-H volunteer program. And based on the amount of time that our volunteers provide to help educate our community, we can value that at around $860,000 for 2019. And through 4-H and other partnership programs with other groups within the office and other organizations within the community, over 28,000 youth were educated. And then we had over 14 million gallons of water saved to Manatee County Utilities customers. And that's through a variety of landscape changes that folks make or in irrigation changes that they make. So we're able to actually track that data in real time as people make changes to their landscape decisions. But this is really just the tip of the iceberg concerning what we offer at the Extension Office. We have a food and nutrition program that works with kids in local schools to provide them with good information on what to eat and how to make healthy choices. We have master money mentors. There's programs that offer kind of relationship counseling. We have a Sea Grant agent who focuses on marine resources and developing our local fisheries. So we really kind of span span a whole host of different topics, and we can be here to provide a lot of resources for you all. So please reach out to us if you're not familiar with us. And with that, I'd like to kind of set the stage for our conversation by doing a poll. So I'm going to launch this poll and go ahead and we'll take a minute for everybody to answer the questions. All right, we got 2 people that haven't voted yet. I can't see which one of you it is, or I'd call you out. Okay. All right, I'm going to go ahead and end the poll, and I'll share the results with you so you can see. So this is a pretty well-informed group of people. We can see 72% of you believe that a key driver of global climate change is greenhouse gas emissions. And then 28% of you believe it's deforestation, which is good because deforestation plays a role in our carbon cycle, and that can have an effect on our greenhouse gas emissions. So those are both good guesses if you didn't know. But it looks like most of you know. And 100% of you said that humans have a major role in global climate change. So that's good as well. So we're starting out from a pretty good place as far as information is concerned. What our key learning points for today are going to be is to talk about how humans have increased atmospheric concentrations of greenhouse gases, what the greenhouse effect is, make sure that you understand that, and then talk about how climate change impacts us today and how it will continue to do so moving forward into the future. So we'll kind of start with a big picture discussion, and then we'll bring it more local, and then we'll end with some kind of key takeaways and actions. And then our subsequent webinars will dive deeper into each of the kind of actionable steps that you can take. So what is climate versus weather? This is a good place to start because I think that we all probably still hear people say, well, the climate's not changing, it snowed today. And for those of us in the know, that seems kind of laughable, but I think that when we're talking to people outside of the scientific community or people who maybe just aren't very well versed in science language, climate and weather can be used interchangeably in common conversation. So it's important to start out with defining what those things are, right? And weather is going to refer to day-to-day conditions of the atmosphere, right? Weather helps you decide what to wear each day or each season, and the weather changes often, right? It can be sunny in the morning and raining in the afternoon. Climate is going to refer to long-term weather conditions. So this is the average of all weather conditions over long periods of time. And when we say long periods of time, we mean thousands of years, right? And we can know what the climate was like thousands of years ago because we're able to look at peat records, we're able to look at soils, at geologic specimens, at ice core samples. So we know what weather conditions were like over these long periods of time. And so global climate, again, it's the average of all the weather conditions over very long periods of time. Weather is day-to-day changing conditions, just to make sure that we're all clear on that. And so when we talk about global climate change, it's important to recognize that there is seasonal and there are cyclical variations in global climate that have occurred in the past that are kind of normal and we expect them, right? Now, climate change is a deviation from that historic variation. So where you may have had, you know, every few hundred years or so, you get a cold spell, or say a volcano erupts and throws a bunch of ash into the atmosphere, that can have an effect on the global climate for a short period of time, right? So that's variability. That's changes that don't extend across, you know, very significant portions of geologic time, or that don't deviate from that you know, kind of historical variability. So this, what you're seeing here, this is Muir Glacier in Alaska. And the photo on the left was taken in 1963, I believe. I have it written down, but 1963, I believe. And the photo on the right was taken in 2015. So you can see, now, obviously glaciers change, right? Between summer and winter, they're going to grow in the cold season and they'll shrink a little bit in the warmer season. But what we're seeing with climate change, right, is a deviation from that variability, a deviation from that natural variability that we would see. So you can see a significant decrease in the size of this glacier in what is considered a relatively short period of time. What are causes of climate change? I think that we first need to start with an understanding of the greenhouse effect, right? And so when we look at a picture of the Earth, we know that there is this thing called the atmosphere, right? And the atmosphere kind of protects us from some of this solar radiation. So the energy from the sun comes and some of it bounces off of the atmosphere. The rest of it comes through the atmosphere, and it's going to either bounce off of reflective surfaces on the Earth, or it's going to be absorbed by the Earth's oceans. And so the greenhouse effect is this concept that by trapping some of that solar energy within the atmosphere, we can kind of have a regulated climate across the entire planet. Obviously colder and warmer locations, but we don't get the drastic swings like you would have on, let's say, like the surface of the moon, right? The side of the moon that faces the sun is going to be warm. The side of the moon that doesn't face the sun is going to be freezing, 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 and, you know, nothing can live. So our atmosphere allows us to have a habitable planet. And obviously there are things that can change that, that climate. And some of them are natural and some of them are caused by humans. And so some of the things that are natural that can cause climate change are actually volcanoes are a great example. And this is one that when I first heard about this, I was like, well, how can one volcano impact the entire global climate? And if you think about the amount of ash and particulate matter that can be sent up into the upper atmosphere, all of that particulate matter then blocks the solar radiation from coming in and hitting the surface of the earth. So what we actually see in some periods of history is, as the result of large volcanic eruptions, we see a decrease in the global temperatures because it's preventing some of that solar radiation from coming in and reaching the planet. Other things can be shifts in tectonic plates. Movement on the Earth's surface can change the amount of available reflective surface or the amount of ocean, right? So the more ocean that covers the land surface, it's going to absorb more of that solar energy. Also, the changes in land surface as far as what is on that land surface. So that's why deforestation can change things, because if we have deforestation, maybe followed by desertification, you can end up with what was once an absorptive surface of solar energy becoming a reflective surface. And so that can change the balance as well. So there are many natural causes of climate change, but there are also human-caused causes of climate change. And one of the main drivers of human-caused is going to be our greenhouse gas emissions and how we're changing the composition of the atmosphere. So we've talked a little bit about this. The water cycle can also influence the global climate, looking at how much water is in the atmosphere, right? If you have more water in the atmosphere, it's going to change that greenhouse gas effect. Again, atmospheric composition. So what kinds of, is there particulate matter in the upper atmosphere? What kind of gases are there? Do we have more carbon dioxide? Do we have more methane? More nitrogen? Those types of things can shift the global climate. And you can see here, this is from NASA. This is annual global temperature change, and we go back to 1880 to about today. But you can see that variability, that up and down, that variability, right? But you notice round about, oh, let's see, what is that? Probably like 1970. We start to see that variability continues, but it's deviating from its normal kind of range. So the variability would normally have a very common range, and then as we move forward in time, you can see the range increases and increases. So you can see that global temperature change has changed very drastically just in the last 4 decades or so. I'm not sure. A question came in about the 1940 spike in temperature. I would have to look into that and see what that was the result of, because that is a pretty drastic deviation from the historical norm. So that would be curious to see. Can't think. 1940 doesn't. Well, we were in World War II then. Interesting. Well, I'll have to look into that and get back to you. So when we talk about the impacts of humans to climate change, right, there are a lot of things that humans do to change our environment in order to make it easier for us to live. Some of those things include changing of the land surface, things like deforestation, things like putting in more impermeable surfaces, concrete, more changing the composition of large swaths of the Earth's surface. So there are those things that we do, but probably the biggest factor that goes into how humans impact climate change is this fossil fuel consumption, right? So we had industrialization that led to the advent of factories, motor vehicles, and as the use of fossil fuels increased over the course of those 50 to 80 years, we can all of a sudden see, okay, so we were using fossil fuels a little bit, coal and things like that, and then all of a sudden we started really relying on coal and gas, and our CO2 emissions skyrocketed. And so there are a couple of graphs here, and the one that I really want to focus on is the carbon dioxide concentration over here on the right. Carbon dioxide concentration. So you can see that we have this, going back to 800,000 years ago, which we can do through ice cores. You see that standard kind of up and down variability, right? And they give you this normal range below 300 parts per million. Well, in 2008, we had an observed parts per million of carbon dioxide in the atmosphere of about 380 parts per million, which is higher than has ever been reported in our geologic history that we can observe as reasonably through ice cores and other testing measures. So what you're seeing here, this green dot, is the 2100 lower emissions scenario. So this is, okay, if we take action, right, and curb our use of fossil fuels, and we stop a lot of the consumptive use that we have right now, we could see somewhere around 550 parts per million carbon dioxide. The higher emissions scenario is one in which we don't take action to curb our fossil fuel consumption and greenhouse gas emissions, and we end up somewhere around 900 parts per million carbon dioxide in the atmosphere. Carbon dioxide acts to hold heat in our atmosphere and increases the global surface temperatures. So you can see the model on the left talks about it shows you the blue is models of temperature change based on only natural forces. And then you can see the pink is models using both natural and human forces. So that would include human greenhouse gas emissions along with natural cycles and changes. So you can see, and then the black line is the observed temperatures. So you can see that this line of observations is tracking pretty well along with the models there. So we can see that these temperatures are rising. So along with our increase of carbon dioxide concentration in the atmosphere, we are seeing an increase in temperature. It's not hypothetical. It's not something that's only existing in models. We see it, right? And not only do we see these impacts as far as temperature, but we're going to talk more about some of the other actual effects that we already see. So I want to pause here and have another poll. I'm going to launch this poll. So go ahead and answer this question, these two questions. And I'm really curious because one of the things that's so interesting to me about climate change is that it seems to be happening on such a scale that makes it really difficult for humans to kind of accept. We have trouble kind of wrapping our heads around these very large abstract concepts. And so it's tough to feel like we can understand it because it's so big. It feels so big to us and we feel so small. Okay, so we've got, good. So gonna end the poll. I'll share results. So somebody still needs a little more information about climate change, and that's great. We're going to talk more in subsequent class series or subsequent webinars on what some of the science says. And I'll show you some more information as we go today. But one of the key takeaways is just that whether or not you can feel confident that humans are causing climate change, one thing that I think everyone can agree on, and I think that this is probably why the second question has no deviation from yes, is that recognizing that the climate is changing is something that most people can do, and it is relevant to your life, right? You can see the changes in the global climate. You can feel the changes in the global climate. So I'm going to stop that share, and we'll go ahead and continue. So when we talk about how can we feel and how can we really see and observe these changes in a meaningful way, I really think that this is a great way to look at this. So when we talk about temperature changes, right, everybody can remember, like, my mom always talks about the blizzard of 72, which was, you know, we lived in Indiana at the time, and the blizzard of 72, there was, like, you know, feet and feet of snow. And so people talk, they remember these large weather events, or they remember that, oh, do you remember the hot summer of, you know, 1989, or, and so I think that because as humans, we don't have the ability to kind of put all this information together in our brain and look at it all at once. It's good when scientists can create these maps and can kind of show us these changes. And so this is the projected change in number of days over 95 degrees. So this is based on historical observations, data that we're collecting now, and then looking down the road from that information that we have to see what is the likelihood that we will have so many days over 95 degrees. So if you look, historical climate for Florida from 1971 to 2000, there's about, you know, in some areas between 15 and 30 days over 95, but in most of the rest of the state between 0 and 15. Sorry. But if you look at the projections, continuing forward from what we've been seeing over the past few years, you know, each year in the last 5 years has been the hottest year on record, right? We've broken that boundary the last 5 years in a row. And so if we continue on the same trends, the projections for Florida show that a large portion of the state will be between 75 or greater days over 95 degrees. So 2041 to 2070, they're looking at 75 days or more of higher than 95 degree Fahrenheit temperatures. And we all know what 95 feels like, right? So that's something that we can relate. We can relate that to our personal experience. We can say, man, yeah, 95 in Florida with the humidity that we have, that's hot. That makes our air conditioners work a lot harder. That makes my electric bill go up really high, right? So this, I think, is a really powerful tool to use when we're talking about climate change impacts on a local scale. What does that look like for us? What does it mean for precipitation, right? Well, if we look at historical precipitation and we look at how that precipitation is increasing, we can see, okay, in 2019, there were far more greater than 1 inch average days, right? So that precipitation, more downpours, heavier rain. I believe in Manatee County, we've already had 10 inches of rain so far this summer. That's a lot. We've gotten a lot of rain in a short period of time. Now, again, that's just weather. That's not looking at the average, but if we look at this average on this chart, we can see that the precipitation has increased. There are different reasons for why that happens, but a lot of it has to do with as air gets warmer, it can hold more moisture. So the warmer the atmosphere is, the more likely it is to be holding moisture. So in Florida, this is real-time data. So this isn't a projection. This is looking at, in Miami from 1970 to 2017, these are the number of days over 90 degrees Fahrenheit. So we can see, you know, in 1970, there were maybe 40 days that they got temperatures above 90 degrees. In 2017, it was 100 days of temperatures above 90 degrees Fahrenheit. This is in Florida, this is Miami, right? So this is actual data, this is not a projection. So we can see that there is a change there in temperature based on our observations. Sea level rise is something else that we're going to have to deal with here, specifically in Florida. So, you know, yes, temperatures are changing globally. That's going to have a vast number of impacts on many different cycles, different kinds of global ocean currents. There's all kinds of things to talk about there. But when we focus locally, two of the biggest factors for how climate change is impacting Florida is related to these temperature changes, these days above 90, and sea level rise. And I hope I can get this to work here for you all. Could somebody type in the chat box and let me know, do you see the sea level rise viewer, or do you still see my presentation? In the Q&A, sorry. Okay, all right. Let me, I'll reshare my screen then so that you can see it. Okay. So this is NOAA, the National Oceanic and Atmospheric Administration. They've put together an interactive map that shows the projected sea level rise based on historical observations in our area. And so this is where we're from, right? This is Bradenton, Palmetto. Our office is you know, right up here in Palmetto. And if we look at the different, let's see, pull up. So if we want to, let's say we want to zoom in on Robinson Preserve area. I'm going to look over here. So you can play with this when you get home, take a look at it. This is NOAA's sea level rise viewer map. But you can see when we start getting out here to these coastal areas, here's Anna Maria Island. Let's take a look at Anna Maria. So when we talk about the current, this is our current mean higher high water. So this is based on fluctuations, tidal fluctuations, okay? And then they take that and they put these projections on top of it. So if we move that up 1 foot, you can start to see impacts in some of these coastal areas. Look at Robinson Preserve, underwater. If we move our mean up, now all of these houses out on Anna Maria are underwater. And imagine what happens with a storm surge or a hurricane. You can see through here, there are some areas that are completely inundated. And then even if we come over towards downtown, right, looking at the Wares Creek area, you can see neighborhoods beginning to be impacted here. If we go up 1 more foot, then you can see large portions of the neighborhoods begin to be impacted. So this is just a, I would take a look at this, play around with it a little bit, see what we're talking about as far as impacts concerning sea level rise. But one of the main takeaways that I wanted to share with you, I'm going to share my presentation back, is that is that we here locally, you know, we talk a lot about climate change and it tends to be couched in these global terms. But here really for us in Manatee County, we were recently identified by a study that was, it was by large mortgage insurance corporation, I believe. I can't remember the name of it right now, but the Tampa Bay Regional Planning Council commissioned this study to be done on sea level rise impacts in our area. And based on available information, we can see that Manatee County is actually one of the counties in the entire country that is set to be most impacted by sea level rise. So temperature changes is one thing, but sea level rise is something altogether else. You know, we have to think about what does our infrastructure look like when we have 1, 2, 3 foot of sea level rise. And there are different projections on how much sea level will rise based on different parameters. You know, one of the things that's interesting about water is that as it warms up, it expands, right? So we see some amount of sea level rise caused just by ocean expansion because the space between the water molecules is actually expanding, right? And then some amount of sea level rise as a result of glacial melting. Let me check the question here. Oh, somebody shared Manatee County GIS has a map specific for our county for sea level rise, so that's good. The NOAA map you can use for anywhere, and it's neat to kind of look around at some of the different areas in Florida. Now, as far as vulnerabilities within our communities, right? I don't want this to just be like all doom and gloom. Don't worry, we'll get to some happier topics in a minute. But one of the things that we're beginning to see as well is more intense hurricanes. So not necessarily more hurricanes overall. You can see this graph does a really good job of breaking it down. The yellow are category 3 and higher hurricanes, and the blue is just all of the hurricanes in general. So, you know, you can see we've got 1970 to 1990, we were between 4 and 6 named hurricanes, and of those 1 to 2 were intense or more than a 3, right? And then when we get into 1995, we start getting up. We had a big year in 95, right? We had 8 hurricanes, 4 of them were intense, and it's actually been going down for the last few years. But the general trend, I think, is that the intensity of hurricanes is impacted by things that are impacted by climate change. So things like sea surface water or sea surface temperature. So how warm the water is going to influence the intensity of the hurricanes. The differences between the El Nino and La Nina, whether those last for a particularly long period of time or not, or they're changing in their variability, that will change how that influences hurricanes. Things like sea level rise and rising groundwater change the impacts that hurricanes have. I think one thing that that I've found very poignant over the last few years in listening to folks talk about the intensity of hurricanes is that we need to start focusing not just on the wind from hurricanes, but we also need to focus on how much rain they're dropping. Because as sea levels rise and as groundwater rises, there's less space for that rain to go. And so when you have a hurricane that drops just inches and inches and inches of rain in a very short amount of time, there's nowhere for that water to go. So we have increased flooding risk. So you can see, I think, already how all of these different components work together, and how you know, things like warming water, you have expanded oceans adding to sea level rise. Warmer water also increases hurricanes. The increasing intensity of hurricanes can change the amount of rainfall they drop. With rising groundwater, we can have increased flooding. So it really is, each piece is going to affect another. Another topic that I would really like to be talked about more often is the impact on our ocean life from climate change, not just related to temperature change, but also related to the amount of carbon dioxide that's dissolved in our water. And as the concentrations of CO2 in our atmosphere increase, there's more mixing between our atmosphere and the oceans. And this in turn increases the amount of carbon dioxide that is in dissolution in our oceans. The greater those concentrations are, we start to see effects on some of our arthropods. Some animals that have calcium-rich either shells or exoskeletons, right? They become impaired by these carbon dioxide-rich waters. When it comes to corals, I think, you know, a lot of us have heard about the problems that are going on with coral in the Keys especially, and in the Great Barrier Reef. But coral, when you talk about corals, they're a symbiotic relationship between an algae, the zooxanthellae, and the coral, right? And as the ocean temperatures rise, these algae become stressed, and then they'll leave the coral, and then it leaves the coral vulnerable, and then they die. And there can be synergistic relationships between things like, okay, the algae leaves and there's a disease present, then the disease can attack the coral. And there are a lot of groups locally that are working on this. The Florida Aquarium is growing corals to try to help repopulate areas of the Florida Keys. I know that I saw a presentation on some research trying to put some kind of epoxy substance around the base of corals that have been recolonized in order to prevent a disease from getting to them. But I think one of the main things that we know, or that we can observe, is that the changes in ocean temperature, right, caused by climate change is the leading cause of coral bleaching. These algae are stressed and they leave the coral bleach, and the coral die. As we lose our abundance and diversity of corals, we lose the main basis for many of our ocean food webs. So you take away, you know, the bottom block on the Jenga tower, and the rest of the Jenga tower starts to fall down. You end up with, you know, ocean predators that we love to eat, like tuna, no longer have the lower fish that they're able to consume, because those fish consumed something that lived in the coral, and the coral's not there for those fish to consume or to live in as a nursery habitat, right? John Muir famously said, you pick out one thing from the universe, expect to find it connected to everything else. That's a paraphrase. But you can really see when we start to talk about climate change, we're talking about the status quo for all life on the planet is changing. What everything on this planet has currently evolved to deal with, to live with, the parameters in which we are alive are changing. And so it's going to depend on species' ability to adapt to these changes, and then to a certain extent it's our responsibility as humans to try to mitigate these impacts as much as possible. And we'll talk more about adaptation and mitigation in a little bit. So along with some of these sea level rise, temperature effects, biodiversity impacts, food web collapse, right, we also have to think locally about our water resources. I think for those of us who live in the greater Tampa Bay area, we're familiar with the fact that some of our counties get water from other counties, right? I know here in Manatee County, we buy some of our drinking water from Sarasota. I know that in Sarasota, they buy some of theirs from Charlotte County, from the Peace River. So there's a lot of exchange of these water resources already within our counties. Pinellas County has no water resources upon which they can rely within their own county. They are exclusively receiving their water through Tampa Bay Water, which is a regional non-governmental group that controls the water resources in that area. A lot of that water is pumped out of Pasco County, and it's transported to Pinellas County, Hillsborough County, for them to use. If you look at this figure here, this is from the Southwest Florida Water Management District. The pinkish purple area, those are areas where groundwater is infiltrating or is infiltrated by salt. So you can see that there's a good, mixing area here, this dotted line, right, where there's still a significant portion of fresh water. But I was actually honestly surprised to see this entire area here. I mean, Manatee County still has a large number of freshwater groundwater resources that have not been impacted by salt. But I'm sure we all know you can't drink salt water. So when we're using groundwater for our drinking water, for our municipal water supply, as sea levels rise, as oceans expand, there will be more of this salt water coming in and pushing up against our freshwater groundwater resources. Part of the challenge with this is that this is going to increase some of our need or our capacity to clean that water, and maybe create new water treatment facilities. Maybe we have to start relying on more expensive methods of water treatment like desalination. So there's a lot that goes into this. One of the attendees informed me that Manatee sells water to Sarasota County, not the reverse. So I was incorrect on that. We do have the Manatee River supplies a large amount of our drinking water. That's what Lake Manatee is for, right? We have the reservoir there. So we do have a large number of surface water resources. We don't use a lot of, a high percentage of groundwater here. And neither does Sarasota County. They use a lot of surface water as well. And one of the reasons for that is this issue with the brackish infiltration into our groundwater resources. So it is really important to recognize that, okay, so let's think back. If we have 100 days when it's over 90 degrees, right, there's probably going to be increased consumption of our water resources. And so again, there's a connection between all of these different impacts or these effects. As far as agriculture is concerned, there are some indications that agriculture in Florida could benefit a little bit from temperature changes, right? If we have warmer temperatures, this will result in probably a reduction in freezing temperatures, which could benefit citrus trees and other fruits and vegetables grown during the winter. So that's one potentially positive impact. Higher summer temperatures will reduce yields of corn and may reduce yields of sugar, peanuts, and cotton. And that depends on sufficient water availability, right? So if you have large agricultural enterprises that are relying on groundwater for irrigation, it becomes difficult when that groundwater is infiltrated with salt to irrigate those crops with it, right? And if you have to purchase treated water, it becomes really expensive to irrigate those crops. Higher temperatures are also likely to reduce livestock productivity due to changes in their metabolism based on the heat. So those are just a few of the potential impacts to agriculture. I would also add to that as temperatures change, as precipitation rates change, I think that we'll see new and novel pests and diseases as well that can impact our agricultural industry. And so we'll have to find ways to deal with those pests and diseases in that changing climate. And I think that we're already seeing that in some areas of the agricultural industry, in particular dealing with things like agricultural weeds, right? So if you have a warmer season, a wetter season, not as much of a freeze, it becomes more maintenance for that agricultural producer to manage the agricultural weeds within their row crops. So that's something that we're already hearing from people, is that there is an increase in some of these agricultural weeds, and potentially there could be an increase in pests and disease. So we've talked a lot about kind of ancillary, or not ancillary, but kind of effects that are outside of us, right? Outside of humans. All of them impact humans, but our health is also affected by climate change, right? Hot days can be dangerous. I think we can already recognize that vulnerable populations, such as the elderly, sick, homeless populations, right? These populations are already vulnerable in high heat situations. We know when we have days that are if we have a heat wave, counties will open up shelters so that people can go in and get cooled off, right? So if we have more days of higher temperature, then it's more likely to increase the need for those kinds of services. People can get heat stroke, dehydration, cardiovascular and nervous systems can be affected. And again, if we look at that, those temperatures above 95 degrees, those temperatures are likely to rise between 45 and 90 days per year. And in 2017, we had less than 15 days per year of those temperatures. Higher humidity increases the heat index and associated impacts on health. So it's easier to get heat stroke when you have high temps and high humidity. And then as the temperature increases, the amount of ozone held at the ground level also increases. And this can have a variety of health effects, aggravating lung diseases such as asthma, and also chronic lung diseases as well. And that goes for air quality in general. If you look at things like the way that certain things like smog, right, kind of kept in cities, these can be impacted by temperature as well. So the hotter the air, the more likely to, especially if they're also humid, right, hot, humid, holding on to things in the air. It's gonna hold more particles, it's gonna hold more compounds in the air, and this is gonna have an impact on our health. And so it's important to recognize that we can have direct human health impacts from some of these climate changes as well. If I haven't convinced you already that the climate is changing, that its changes affect us and that they impact us, here's a short look at the economy and how the economy can potentially, here in Florida, directly be impacted by climate change. So we have billions of dollars in waterfront real estate, right? They are at risk from rising seas, just in general, and then also from increased intensity or frequency of storms, and also insurance and taxes are increasing to try to compensate for those potential impacts. When we look at current models, talking about things like sunny day flooding, where because sea level has risen, when there's a high tide, you get flooding, right? That's sunny day flooding. By 2045, we have nearly 64,000 homes in Florida facing flooding every other week. And then by 2100, the number of at-risk homes jumps to 1 million. Okay, so this is based on a study from last year by the Union of Concerned Scientists. And again, this is based on our observations now on what we're seeing as far as flooding and how many homes could potentially be impacted based on what we're seeing now. And then if you think about the impact to, let's say you have beaches where you have sea level rise, right? You have dune ecosystem flanked by condos with beach in front of it. As sea level rises, you lose your beach, right? And what are you gonna knock down the condo and turn that into a beach? it becomes difficult to figure out how you're going to compensate for the lack of that resource, right? So a lot of our tourist industry here in Florida relies on having these beautiful sandy beaches, as well as our other types of outdoor recreation like kayaking, paddleboarding, and recreational fishing. And so looking at this, a study done last year showed that our tourism industry could lose $178 billion annually by 2100. As far as fisheries, you talk about, this is one aspect of, there's people that come to Florida from all over the world to fish for fun. But we also have a large fisheries industry here in Florida. And there are going to be, and already are, impacts to our fisheries and aquaculture because of climate change, right? There will be changes in ocean currents, in the thermal structure of the water. So where the different temperatures, because there are different temperature gradients as you go deeper, right? That's going to change the composition of things. We've already talked about coral bleaching. So fisheries could be significantly impacted as well. And so that takes away from another source of income for folks who live in the state. So for the Tampa Bay region specifically, there was an economic study done by the Tampa Bay Regional Planning Council in 2017 that looks at, based on a highest projection of sea level rise of 2.95 feet, which is the top end of the projections, what are some of the economic impacts we can expect in our area, in the Tampa Bay area? And that's the Pinellas, Hillsborough, Manatee counties. And I think Pasco might be in that group too. But if you look at this, these estimates, these are pretty stark. Looking at value of submerged residential property. So this is all property that's submerged and unusable. The estimate there is $14.9 billion. Value of submerged commercial property, $1.3 billion. Cumulative loss of property taxes, $5.4 billion. Job losses, okay, 17,000 jobs lost. So I really want to drive home the point that there are so many ways that we, in particular in Florida, are very vulnerable to some of these changes, and recognizing that I just read an article earlier today that it says that basically we have about 6 months to globally kind of really change what might happen as far as the climate is concerned. To a certain extent, most of this change is already baked in, right? There's a lag time in when impacts are seen and the cause started, right? So because of this lag time, we're not yet seeing impacts from the increase of CO2 from 10 years ago, let's say. That's not exactly accurate, but I just want to show you that there is that lag time there. So based on available information, right, this group of scientists, they said, okay, we've got, maybe we got 6 months. And that's including something that's really interesting, which, because of the coronavirus pandemic, there was a 17% drop in global carbon dioxide emissions in April. And so we can, that could be one silver lining, but something that these scientists were looking at was the fact that everybody's going to be trying to really bring their economies back, roaring back to life. Right? We all want to see that. We know people who have been personally impacted by loss of a job or loss of hours in their job. So everybody is going to be trying to bring these economies roaring back to life. And with that is going to be increased consumption and use of fossil fuels. So, so they were kind of looking at that and saying, okay, if we're going to do something, this is really the year we have to do it. So we're going to pause because that was a lot of information. And I think that this is one reason why the climate change discussion is often kind of just pushed out of our minds or pushed to the back burner, or we feel like this is too big, right? We step back and we're like, I'm just one person. This is too big. I don't know what to do about this. I can't handle this. And so I think it's important for us to pause, and I'm gonna put another poll out. And I'm curious to see how you respond. I'm gonna check the Q&A while you guys are. Okay. I'm gonna end polling here and share the results with you all. So apparently I scared you. I'm sorry. 100% of you are, yes, concerned about the potential impacts to Florida from climate change. So that's good, right? You can recognize that it's something that we need to think about and we need to care about, and we need to, you know, maybe think about what we can do. I had a question come in the Q&A. Have we determined what is the point of no return? There are estimates based on the amount of CO2. You know, we had thought it was 400 parts per million was kind of that tipping point. We reached 400 parts per million, I believe, early last year, at least in one testing location in Hawaii. And, you know, we're still kind of looking at that. There's so much that goes into figuring out what that point is, right? What is acceptable for one person may not be acceptable for another person. So what is an acceptable threshold of impact? Can we accept that 10 million people die because of heat-related illnesses every year, right? I don't think that, you know, I feel like we probably can't, but those are the kinds of decisions or thresholds that you have to think about when you're trying to figure out what that point of no return is. Are you talking about from a human health perspective? Are you talking about to avoid global ecosystem collapse? There's a variety of ways you can answer that question. I think that for the basis of our discussion and moving forward in future webinars, you know, I really want to reiterate the fact that we should be acting like we're already at that point, and that we should be doing everything we can to mitigate and adapt. We'll talk about what that means in a minute. So everybody's concerned. Okay, 78% think that they can make meaningful changes. One person says that I'm only one person and my actions don't matter. One person says that they lack the knowledge to make any significant changes. So I will change that one person who doesn't have the knowledge. We'll give you some knowledge. And then a couple of people think that combating the effects of climate change falls on the shoulders of elected officials. And you are right. There is a lot that can be done from that level. And we'll talk about ways that you can actually influence that potentially. So stop that share. Close that. Okay, there we go. I have so many screens open here. Come on. There we go, got it. So what does it mean to adapt or mitigate? I've used that phrase a few times. And you know, when we look at global climate change and we talk about, okay, we know these things are happening. We can observe these things are happening. We know that in order for ecosystems and for human life as it currently is to survive on this planet, we're going to have to change some of our behaviors. Are there any things we can do to stop that from happening? And so that's where adaptation or mitigation come into play. So adaptation is going to be ways that we can change our behavior as a result of climate change effects. So things, for instance, like change in land use or relocation. So if the sea level is rising, we're going to move off of those areas where we're likely to see inundation, and we're going to build elsewhere, right? That's an adaptation. Upgrades or hardening of buildings and infrastructure, different kinds of health programs, right, to improve community health, to make people more resilient to deal with those temperature related health effects, or those air quality related health effects. Mitigation is going to be actual, what are steps we can take to physically reduce the amount of greenhouse gas emissions? What can we physically do to actually change how much of those greenhouse gases we're putting into the atmosphere? Is there any way for us to get some of them back out? And so looking at things like energy conservation and efficiency, renewable energy, obviously moving away from fossil fuels and using more renewable energy sources. But that's only a part of it, right? Thinking about improved fuel efficiency and sustainable transportation. And I would add to that as well, when we look at our current situation, right, there have been, all of a sudden, the way we work changed, right? People were forced because of a virus to go to an alternative work location. I'm talking to you from my dining room right now, right? And I think that what we might see moving forward is that people might recognize that workers are able to be as efficient when working from alternate work locations. And this can significantly decrease our greenhouse gas emissions if we are not commuting, right? And oh my gosh, imagine the human health impacts of not having to commute, the stress levels. So thinking about ways that we can, how do my daily actions potentially impact how much fossil fuel I'm going to use? Can I bike to work? Is that an option for me? If I can't bike to work, I live way too far away, is there a reasonable bus that could get me there? If there's not, can I talk to my employer about having a flexible work schedule that would allow me to work from home some days a week? Those are all things that are related to mitigation, that are actions that we can take as individuals that do have measurable greenhouse gas emissions impacts. Things like carbon sinks. So I know, maybe it was 6 months ago or so, there was a lot of kind of wildfire going around the internet about this idea that we could plant 1 billion trees and we'll save the global climate. And planting trees is great. And it's a good way to, we should be thinking about reforestation in general, but something that's even more impactful to the global carbon cycle is keeping trees in the ground. So there are some creative solutions out there thinking about, can we pay logging companies to keep trees in the ground? Can we give them a subsidy or something like that to keep their trees in the ground and not cut them down? Are there ways that we can protect things like mangroves and seagrasses that act as valuable carbon sinks within our marine environment? There's actually a study that came out quite a few years ago that showed mangrove ecosystems are 10 times better at capturing CO2 from the atmosphere than their tropical rainforest counterparts. So, when we talk about, I could go on and on about mangroves and how good they are and how important they are for local resiliency, but in the context of greenhouse gases, they are 10 times better at pulling CO2 out of the atmosphere than a tropical rainforest. So figuring out mechanisms to keep those ecosystems intact, those are mitigation strategies, right? So we can have personal adaptations, but we can also have personal and individual mitigation strategies. And all these things can be done, you know, we can practice them at the individual level, but we can also encourage them to be implemented and practiced at an organizational level or at a community level. If you work for a small business, is there any way that you can talk to the owner of the company about instituting some of these telework policies that will significantly reduce your greenhouse gas emissions, more than, like, you know, buying carbon credits or something like that? Think about ways that you can physically reduce the amount of greenhouse gases that you're using. So what is being done locally already? There's a lot going on, and a lot of people have recognized, and I think they've been woken up to the fact that here within our region, we are uniquely vulnerable to some of these challenges. And so, you know, just a couple years ago, City of Sarasota created this climate change vulnerability assessment and adaptation plan. And I think it's a great step for a local government to actually look at what are we doing locally. Are we vulnerable to sea level rise? What are our greenhouse gas emissions? I know that Manatee County is in the process of getting a report on their greenhouse gas emissions as well. And I think that's wonderful, right? First step for local governments is to look at what they're currently doing and figuring out ways that they can feasibly make changes. So these are some of the things that are happening. You know, different counties and municipalities are looking at these things. They're formalizing reports. They are engaging with local organizations to try to figure out ways that they can creatively deal with some of these issues. The Tampa Bay Regional Planning Council, that I've mentioned a few times, has been doing a lot of good work locally. Just looking at the Q&A there. And so, you know, there are other groups and organizations that kind of work on these topics. There are groups like the Audubon that does a lot of work related to this. So you can find a group to get engaged with, or you can take individual actions. You don't have to go out and become like a climate change warrior, but recognize that this is not abnormal at this point. It is recognized now widely across the entire world that unless we address these issues and figure out ways to adapt or mitigate, there will be significant human health and economic impacts that will be felt by these local communities. So what can you as an individual do? And the first thing, pat yourselves on the back, is get informed. So congratulations to you for attending this webinar today. Go ahead and do it. Pat yourself on the back. Feel good. It's important to feel good when we talk about global climate change, because it's a big thing to think about, and so we don't want to get overwhelmed. Hold yourself accountable. Recognize how your own choices can have an impact. Do you really need to drive the SUV to, you know, 30 miles away to go to the grocery store? Or could you ride your bike around the corner to the local grocery store, right? Are there small things that you can do individually? If it's reasonable, can you set your thermostat to run at 80 or 82 during the day while you're not in the house? That's a big energy savings, and energy at this point equals carbon, because we really, here in the state of Florida, despite being the sunshine state, we don't have a significant amount of our energy coming from renewable sources. Unplug. Find ways to reduce or make your energy use more efficient. There are lots and lots of ways that you can increase your efficiency. Look for things that continue to draw power while they're plugged in, even if they're off. So that's a really important thing to do. Look around your house. You can buy little meters that will let you know what things are still drawing electricity, even if they're not currently turned on. If they still power a little red LED light that tells you that it's off, then it's drawing electricity, and you can unplug it. Travel smarter. Sometimes you have to fly. You're going to visit a relative you haven't seen in 10 years. they live in the UK, right? Doesn't make sense for you to take a train to the eastern coast and then to take a boat across the Atlantic, right? That doesn't make sense. Figure out ways that you can make your travel more efficient. If you don't have to fly, don't fly. If you can drive, take the most fuel efficient vehicle. If you're going with other people, make sure you carpool, right? So that's just, think about how you're traveling. And, you know, maybe it means taking fewer overseas vacations. If you're one of those people that can afford to do that, I think that travel is great, but maybe figuring out, okay, maybe only once every 5 years I'm going to go overseas, because that's a huge amount of CO2 when you travel by plane long distances. Think about how the food that you consume contributes to climate change. We'll talk more specifically about this in an upcoming webinar where we talk specifically about food choices. But, you know, recognize that, you know, just because if you go to Costco and you buy all organic, doesn't necessarily mean that you have a low food footprint. There are calculators out there. There are lots of different ones, but if you look for your food footprint, your carbon footprint based on your food consumption, you can kind of answer some questions about yourself and see kind of where you fall. You know, one of the big things that I like to emphasize at Extension, especially because we're, you know, pretty heavily ag focused, is think about when you're at the grocery store, you can buy organic produce from Argentina, or you can buy produce from a farm, you know, in eastern Manatee County. That produce might not necessarily be organic, but its carbon footprint is going to be significantly less than that produce that was shipped from another country. So sometimes, and you know, I recommend, you know, if you're worried about pesticide residues and things like that, look into it, make yourself, again, get informed, figure out exactly what your risk is, but think about how the choice that you make about where your food is coming from and how far away it's traveling from could impact the climate. Shopping smarter, and I would say, to add to shopping smarter, we're going to have a whole webinar talking about consumption, but shop less, right? Do you need a new pair of jeans every month? No, I don't think you do. Is there a way, you know, if you're a consumer of clothing, I highly recommend looking into the different thrift options that are available. There's even online thrift now. Think about buying something for its lifetime. So rather than buying something that's cheaper now, that you're going to have to replace in 2 years, pay a little more upfront if you have the luxury of doing that. Some people don't, but try to get something that you're either going to be able to fix yourself or that isn't likely to break over the course of the time that you're going to have it. That way you end up producing less waste. And then, so these are kind of, I organize these this way because these are kind of personal lifestyle decisions, right? These are things that you can kind of, you can do personally within your own lifestyle to make changes that do have a greenhouse gas emissions impact. These action items are things that you can choose to do that will have a broader impact on your community scale, at the state scale, and at the national scale. So, you know, no political party affiliation is necessary for someone to have a good climate scorecard, right? You don't have to belong to any specific political party to you know, have a good record on climate. Wanting to increase the availability of renewable energy jobs in the state of Florida. If somebody wants to do that, hey, that's good. You should vote, you know, with your heart on that, and look at the candidates and look at where they stand on some of the issues related to climate and sea level rise and resiliency planning. If you have the ability, organize. Get with a group of individuals, get with a group that already exists, talk about ways that you can do different you know, community actions to improve our either adaptation strategies or mitigation strategies. think about if you, again, if you have the luxury of this, you know, if you're investing money, look at the companies that you're investing in and invest in companies that are promoting a climate forward approach. You know, if you work for an organization that that does invest money, talk to the folks at your organization about who they're providing money to and whether or not you maybe need to pull back on some of those investments and put your money in other places for organizations that are more climate focused. And then, you know, get out there and show your support. Make sure that as people in your community talk about these issues, you provide them with the best information you have. And you can recognize, I think, how climate change will impact our daily life. And so I think that you can share that information with your community, with your families even, and in showing your support for this climate science and for climate forward and you know, thinking ahead approaches to dealing, to adapting, to mitigating, then you know, slowly in a grassroots fashion, we can get more people on board. Here are some additional resources. Florida Sea Grant has some great climate change publications, as does the Southeast Florida Climate Compact, their climate action plan. Climate of the Southeast United States has some really great information as well. So again, don't just take my word for it. The first step is getting informed. So go out, read a bunch of information. Feel free to email us and ask us questions. We will answer them as best we can. And if we don't know, we will find somebody who does know. These are just some of the references for the materials and graphics that I used in the presentation. And so somebody wrote, oh no, who buys a pair of jeans every month? I want their job. Yeah, we'll talk about consumption in a future webinar, and specifically about fast fashion and the way that the fashion industry affects climate. It's much more than you would anticipate. If no one else has any other questions, then we are done for the day. And I just want to thank you all. And again, don't feel like you have to attend every one of these. Jump into the next webinar if you can. Otherwise, if you register and if you encourage others to register, we do email out the recording to everyone that has registered for the webinar. So if you weren't able to attend today, or if you know somebody who wasn't able to attend today, encourage them to register and they'll get the recordings from the presentations. Okay, I've got a few questions. Okay. All right, thank you all. Oh, one more. Okay, great. Thank you. Have a wonderful day, everyone.